Alright, hello everyone, this is Mr. Crozier. I want to walk you through problem 2 from our worksheet right here. I have all the work here, and all the work, everything worked out, all the answers that you need, and I'll just walk you through the steps and show you how to use the calculator. Alright, so we have the same chart of times and velocities, and I've graphed them here. 0 to 60, and velocity goes up, then it slows down. And part B, estimate total distance using right Riemann sum. So what would you do for an area if you came from the right side right here? Well, the shorthand notation is just 10 times all of those on the right, and for C is the left hand Riemann sums, 10 times all of those on the left, because I just factored out a 10 here. Part D, it says estimate the total distance using trapezoidal sums, and I just make yourself a neat chart organized like this. It's 1/2 the height, which is the width in this case, and the left and the right endpoints. And notice the pattern here: 0, 18, then 18, 27, 27, 45. It's just you're building this. If you're looking at this one, you're building this trapezoid right here, and the last 2 points are the 30 and the 20 right there. It's these 2 points right there. Alright, when you get to part E, then it says make a scatter plot on your TI-84, and you get that by going to Stat and Edit and putting these values as list 1 and these values as list 2 right down your table. So there they are. There's the top row, there's the bottom row, and that's it. And then you go to Y equals. And if you come up here to the top, if you turn on this plot and hit enter, now what you see is it's highlighted, meaning plot 1's on. Everything else is off on here. Plot 1 is on. The window I'm using is from -20 to 80, counting by 10s, -20 to 70, counting by 10s again, hit graph, and there's my scale, and there are my points, and it looks just like this one here. So just make sure you hit Y equals and turn that plot on. You can go up here and you can turn that plot off, and now it's off and there's nothing on the graph. You can come back here and turn it on, and there you go. Alright, so we have it plotted. Just put a little check mark there, and then now what we want to do is find a model of the data as a quadratic. If you look at this data, it goes up and it goes down, and that is a quadratic equation. It's actually a negative quadratic equation, and the one I came up with is right here. It is negative 0.037x squared and 2.58x and a constant right here. Now where do these coefficients come from? Well, this is the A value and B value and C value in this standard form right here. Well, thankfully our calculator does the work for us, and it's right here. Stat calc 5. So stat, go over to calc, down to 5, quadratic regression, and it's going to take list 1, list 2. If you just hit enter through these and calculate, there's your coefficient. So this easily gives you the coefficients that you need to write your equation. Again, the formula, or on the calculator, it's stat, calc, quadratic, and right there is quadratic, cubic, quartic, and linear regression, natural log, all kinds of different regression forms you can use. Alright, let's close this. Go up to Y equals, and here I have it typed in already. So I'm just going to turn this function on by clicking on the equal sign, and now if I go down, I have the points on, they're highlighted, and the equation on, and if I hit graph, right there's the best quadratic that I can come with to go through those points. Again, not perfect, because it doesn't match exactly, but somewhere above, somewhere below, and this line is right in the middle. It's a line of best fit. It's a curve of best fit. So there's the equation I need. And now for h, go ahead and evaluate the definite integral. 2 ways to do that. You can go to math, and let's see here, right here, our integral. We can go at 0 to 60. And I can either type in that whole function again, or a nice shortcut we know is to hit this variables button right here that says variables and function and y1. And now what it's going to do is it's going to integrate from 0 to 60 of that function we've already named. So I don't have to type it all in again. Press enter, and there's that value, 1818.6. And what you'll notice is this is right in between the left and right Riemann sums, very close to the trapezoid, and all of these are close estimations to this distance under the curve. And I'll show you one more thing to do. If you go to your graph, if you hit this calculus button up here on the graph, second calc, you can come down here and do choice 7, which is the integral. Press enter. It asks you for a lower limit, press 0. Asks you for an upper limit, press 60. Hit enter. It will shade the area under the curve for you from 0 to 60. Remember, my graph went out to 70 here, but 0 to 60, and it gives you that same number. It's that same number we found here. So you can see it on your calculator. Again, that is second calculus and number 7. And just enter your lower limit and your upper limit, and it will shade it for you and do the math for you. All right, hope this helps.